Inverse trigonometric functions. Let's recall functions, their domain, range and graph. So first one, we'll start with sine inverse x. We say y is equal to sine inverse x, and we know that sine inverse x is nothing but theta. So domain for this function is closed interval -1 to 1. Range is closed interval minus pi by 2 to pi by 2. And graph for this function is this particular branch we consider, right? On the x-axis from -1 to 1, on the y-axis we consider minus pi by 2 to pi by 2. Second function, cos inverse x, domain is closed interval -1 to 1 and range is closed interval 0 to pi. And this is the graph for cos inverse x. All of you know how to get these graphs. Next function is tan inverse x. For tan inverse x, domain is whole set of real numbers. So we can write open interval -infinity to infinity. X can take any real value. Range is open interval minus pi by 2 to pi by 2. And this particular branch of this curve we consider, that is which passes through the origin, right? Next one, cot inverse x. For cot inverse x, again domain is whole set of real numbers and range is open interval 0 to pi. Graph for cot inverse x is like this. Then sec inverse x, domain is -infinity to -1 union 1 to infinity. That means x can take values greater than or equal to 1 or less than or equal to -1. So this function excludes points which lies between -1 and 1. Then range is interval 0 to pi, close interval 0 to pi, excluding the point pi by 2. And graph for sec inverse x is this. Then cosec inverse x, domain is -infinity to -1 union 1 to infinity and range is close interval minus pi by 2 to pi by 2, but exclude this point 0. Why we are excluding these points? Here we have excluded pi by 2, here we have excluded 0 because function is not defined at this points. Now we will discuss properties of inverse trigonometric functions. Property 1. Sine inverse of sine y is equal to y, where y belongs to minus pi by 2 to pi by 2. Then cos inverse of cos y is equal to y, provided y belongs to 0 to pi. Tan inverse of tan y is y, provided y belongs to open interval minus pi by 2 to pi by 2. Then cosec inverse of cosec y is equal to y, where y belongs to close interval minus pi by 2 to pi by 2 minus the element 0. Sec inverse of sec y is y, where y belongs to interval close interval 0 to pi minus pi by 2. And cot inverse of cot y is y, where y belongs to open interval 0 to pi. So you will observe that for this function we have interval minus pi by 2 to pi by 2, right? For this again minus pi by 2 to pi by 2, and there is one more, this one again we have minus pi by 2 to pi by 2. And for remaining three functions, this one this one and this one, we have considered interval 0 to pi. Now let's consider a few examples. First example. So what will be the value of cosec inverse of cosec pi by 6? This is equal to pi by 6. Since pi by 6 belongs to minus pi by 2 to pi by 2 minus 0. So in the given range this value lies, therefore its value is pi by 6. Next one. Now we have sine inverse of sine 1. Can we write it as 1? Sine inverse of sine 1. This 1 is in radians. So sine inverse of sine 1 is 1 because 1 belongs to, now which interval we will have to consider? Interval is minus pi by 2 to pi by 2. Now what is the value of pi? Approximately we consider 3.14. So minus pi by 2 means it will be minus 3.14 upon 2. So it will be minus 1.57. And pi by 2 means 1.57. So you must check whether this value lies in this interval. So 1 belongs to this interval, therefore we can say sine inverse of sine 1 is equal to 1. Next one. Now cos inverse of cos 7 pi by 6 is equal to, can we say it is equal to 7 pi by 6? Can we write it as 7 pi by 6? No, because 7 pi by 6 means you can write it as pi plus pi by 6. That means angle will be in the third quadrant. And for cos inverse, what we require is interval 0 to pi. Value should lie in the interval 0 to pi. Okay. Now cos of 7 pi by 6 is minus root 3 by 2. So corresponding value minus root 3 by 2, corresponding value for minus root 3 by 2 in the second quadrant is 5 pi by 6. Therefore cos inverse of cos 7 pi by 6 is equal to 5 pi by 6. Property number 2. Now we have sine of sine inverse x is equal to x provided x belongs to closed interval minus 1 to 1. All these intervals are very important. Then cos of cos inverse x is x, where x belongs to minus 1 to 1. Tan of tan inverse x is equal to x, where x belongs to r. X can be any real value. Cosec of cosec inverse x is x, provided x is either less than or equal to minus 1 or it is greater than or equal to 1. Similarly, sec of sec inverse x is equal to x when x is either less than or equal to minus 1 or greater than or equal to 1. And cot of cot inverse x is equal to x for x belongs to R. Let's try some examples. So first one, sine of sine inverse half. Can we say that it is equal to half? Yes, this is equal to half because half belongs to the interval minus 1 to 1. Let's check the next one. Sine of sine inverse 15 by 16 is equal to, can we say 15 by 16 again? Yes, because 15 by 16 belongs to this interval minus 1 to 1. Next, cos of cos inverse 17 by 16. Is it equal to 17 by 16? No. Why not? Because range is minus 1. See, this is the interval, required interval, minus 1 to 1. Now 17 by 16 exceeds 1. Therefore, this value does not exist. Next, property number 3. Sine inverse of minus x is equal to minus sine inverse x. Tan inverse of minus x is equal to minus tan inverse x. and cosec inverse of minus x is minus cosec inverse of x. All of you know that for these three inverse trigonometric functions, see, this is the interval we consider, minus pi by 2 to pi by 2. That means value lies either in the first quadrant or in the fourth quadrant. Whenever given value is positive, you will get your answer in the first quadrant. Whenever given value is negative, your answer will lie in the fourth quadrant. So sine inverse of minus x is nothing but minus of sine inverse x. Similarly for tan inverse and for cosec inverse. Say for example, sine inverse of minus half you want to find. So minus half, where is the point minus half? This is the point minus half. So this is the point minus half. It corresponds to minus pi by 6. And minus pi by 6 you can write minus of sine inverse of half. Right? So answer for this problem is minus pi by 6. Let's proceed with next three inverse functions. Now in case of cos inverse, cot inverse and sec inverse, see the right hand side. Cos inverse of minus x is pi minus cos inverse of x. Cot inverse of minus x is also pi minus cot inverse x. And sec inverse of minus x is pi minus sec inverse of x. Now what happens here exactly? See, for these three inverse functions we consider interval 0 to pi. So value lies either in the first quadrant or in the second quadrant. Whenever given value is positive, you are going to get answer in the first quadrant, and whenever value is negative, you are going to get answer in the second quadrant. Right? So cos inverse of minus x is nothing but pi minus cos inverse of x. Let's check with example. Say for example, if you want to find cos inverse of minus half, cos inverse of minus half, so that is equal to 2 pi by 3. Minus half corresponds to C, 2 pi by 3. But this 2 pi by 3 we can write it as pi minus pi by 3. Right? Pi minus pi by 3 is 2 pi by 3. So this is nothing but pi minus. Now what is pi by 3? How will you write pi by 3? Pi minus cos inverse of half. So cos inverse of minus x is equal to pi minus cos inverse of x.